Hello everyone and welcome back. My name is Mr. Cobalt and today in this video I'm going to go over gas evolution reactions. And so just like the precipitation reactions and the acid-base neutralization reactions, the gas evolution reactions are going to be where you are producing a gas in the products. So you can go about predicting the products in the same usual way, so as you did in the precipitate reactions and the acid-base neutralization reactions. So what you can see here is a few examples where you either get a gas right away, right? So here, if you do the inside ions, so lithium and sulfate go together to form lithium sulfate, and then you have the hydrogen and the sulfide are going to go together, and so that's going to form your dihydrogen sulfide here. So with regard to this is your gas, and so you have to recognize that if you form H2S, that's going to be a gas, and that's going to be a gas evolution reaction. And so that's an example of where you can do the inside and the outside again, because here you're going to have your ionic substance, you have an acid here, and so that's going to break apart. But that's not always going to be the case where the gas is produced right away, as we have here. In a lot of these reactions, it's going to produce an intermediate first, and then that intermediate is going to break down. So if you are given a problem where you're asked to predict what the products are going to be, you have to be careful with the intermediates. So for example, if I am doing this one, if they give me these two reactants and they ask me what are the possible products, what I can do is I can take the inside ions, right? So the chloride and the sodium are going to go together, and I would form sodium chloride, and it's aqueous because it dissolves in water. But then I could take the H and the anion here, the polyatomic ion. This is my bicarbonate ion, and I could put those together, and I get my carbonic acid, and that's going to be aqueous. Now I might think I'm done. And from before, we could look at this equation and say, look, I have aqueous on this side, and then I have aqueous on this side, and everything's floating in water, and nothing's been produced, right? So I might think this is no reaction based upon the fact that I'm not forming a solid, I'm not forming a gas, I'm not forming a liquid, right? So I might think, oh, this is a whatchamacallit, a no reaction. There's no reaction going on. But you want to pay attention to this here, right? So this, your carbonate ion can break down into water and a gas, carbon dioxide. So in a lot of these, if you just subtract out the water, you'll get the gas. So if I subtract out H2O, so I take out one oxygen and I take away the hydrogens, so that's going to give me my water, H2O, and then what's left over is carbon dioxide gas. So those would be my products. So these two and this one would ultimately be my products. So that's, I don't want to stop here. I want to stop here. So ultimately the products are going to be my reactants form water, carbon dioxide gas, and my salt. Same thing for this one here. So again, I can put the inner ions together, put that, and I get my sodium chloride. I put the hydrogen and the ion here, my bisulfite ion, and I put those together. And this time I get my sulfurous acid and my salt. And again, if I would stop there, I would not be correct. So here, this is going to break down, and if I subtract out water from here, right, I remove the two hydrogens and one oxygen, so I'll get water again, H2O, and what's left over is SO2, so sulfur dioxide, and that is also a gas. So in this reaction, If my intermediate is sulfurous acid, that's going to break down into water and sulfur dioxide. If my intermediate is carbonic acid, then that's going to break down into water and carbon dioxide. So carbon dioxide is the gas, sulfur dioxide is the gas for this one. What if I have an ammonia substance with ammonia? So again, if I can predict my products, I have my NaCl. The inner ones go together. That's going to be my NaCl. And then my OH and my ammonium, so hydroxide and ammonium are going to go together, and I get that one, and that's aqueous. So again, I have to be careful. So if I subtract out water from this, right, so I get H2O, what's left over is NH3, which is the ammonia, and that's going to be a gas. So I'll get ammonia gas coming out. So you have to be careful with these intermediates, and so you have to look out for them in order to identify your reaction as a gas evolution reaction. So if you stop here, then you would not be correct. So you have to recognize that if one of your products is carbonic acid or sulfurous acid or ammonium hydroxide, then that's going to be an intermediate that's going to break down into water and your gas. So you subtract out water, and what's left over is your gas. So here's a little table. So if you have sulfides, if the reactant is a sulfide, then be on the lookout for H2S gas. So be on the lookout for that one. If you have carbonates or bicarbonates in your reactants, then be on the lookout for carbonic acid. Okay, if you get carbonic acid, then that's going to break down into water and carbon dioxide. So carbon dioxide would be your gas. If you have a sulfide or bisulfite as part of your reactant, then be on the lookout for your sulfurous acid. That's going to break down into water and sulfur dioxide gas. And then if you have something with ammonia in it, be on the lookout for NH4OH. If you form the ammonium hydroxide, that's going to form your ammonia. And again, it's water and the gas. So you take out water and you get leftover ammonia. So I hope this is helpful as far as gas evolution reactions go. If you like the video, like it, share the video with your friends, make a comment in the comment section, and subscribe to the channel, and ring the notification bell. Thank you for joining me, and I'll see you next time.